ongoing automatization throughout all processes cause an increase in scenarios of autonomous vehicles and employees working side by side. Automated guided vehicles, so-called AGVs, collect and process a wide amount of data to meet the requirements of safety. In addition, areas with limited field of vision, like intersecting corridors, render it necessary to further reduce speed to ensure safety. This happens at the expense of process efficiency. Due to our consortium with Ericsson, KION and SICK, we develop our solution from the very beginning in an industry-oriented way. Our aim is creating a solution for easy and rapid industrial rollout. With the project, we make situation-based behavior possible. In this setup, the AGV from KION interacts in the Ericsson 5G infrastructure with sensor systems from SICK. This is directly tested here in the production of demonstration factory Aachen. Intersections in factories bear an increased risk of accidents as different traffic participants cross their way. A wide range of sensors are involved in this project. New possibilities are created by means of sensor fusion. The 5G network transmits data from AGV, camera and laser scanner with low latency. Additional UWB sensors add a second localization information. In case no object near the intersection is detected, the AGV can cross without stopping or slowing down. Sensor and localization information prove an empty intersection. The information to continue the drive at full speed is sent to the AGV. If the AGV is close to the intersection and an object is approaching in distance, the AGV is warned to slow down as a precaution. Sensor and camera information detect a far object which is not in the range of the AGV detection. The information to cross the intersection slowly is sent to the AGV. If an object is critically close to the intersection, the risk of an accident increases and the approaching AGV is therefore stopped. Sensor and camera information detect a close object. The intersection is declared occupied and critical. The information to stop is sent to the AGV.
Yeah, but it's a really very nice and impressive video demo. So many thanks again to Ericsson, KION, SICK and the Center Connected Industry in Aachen for preparing that for us. And now it's a great pleasure to welcome some of the experts here in the virtual studio. And first of all, I have the pleasure to talk to Andreas Höll from SICK. Andreas, what was your contribution to the project?
In this project, we are following the path of functional safety to make it more dynamic and more flexible in the future. At the end of the day, we want to make it useful for the industry. From SICK's side, we bring in several sensor-based automation functions, like an ultra-wideband system for localization, object tracking with laser scanner, and a 3D camera to detect objects on the intersection. All collected information, together with the AGV information, will be merged in the edge cloud to solve the issue for the functional safety. Therefore, we believe we need the 5G capabilities to bring all information together.
Yeah, thank you very much, Andreas. And my second question now goes to Ansgar Bergmann from KION. Ansgar, what are the technical advantages of such a cooperation and solution for a supplier like the KION Group?
Hello, thanks for having the possibility to give you a short statement from the KION Group. The vehicles of the different brands of KION are highly digitized and have excellent mechanisms to protect the surroundings against accidents. But nevertheless, warehouse layouts are always a challenge due to the limited available space. The lack of opportunities to see around the corner means that usually systems must reduce their performance in order to be 100% safe. In this case, the cooperation of the involved partners who contribute their special know-how in this context is very, very helpful. At the end, the cooperative systems like this one can create new solutions by giving information to the AGV which are normally not available. An increase of speed in interlogistic processes becomes now possible without compromising the safety.
Yeah, thanks, Ansgar. That's very insightful. And last but not least, I have now the pleasure to welcome Ralf Wellens in the virtual studio. So, Ralf, why is Ericsson part of this project here?
Hello, and thank you very much for having me here. We in Ericsson have engaged over the last couple of years with various industry partners in order to find out how 5G can solve industrial communication problems. For us, it has been very fruitful to work with industry players, as we are doing also in this project here. They have provided us with their real needs and requirements, and coming from communications industries, we only had little understanding of these industry demands. So in such cooperation projects, we learn a lot about what industries need. And with this understanding, we are in a much better position to provide feedback into our product development and to make sure that our product supports such customers. Then another aspect is, of course, doing real projects with partners gives us insight into how 5G systems work in real factory environments. And these learnings are, of course, extremely valuable for us as Ericsson as well.
All right, so I'm just wondering, what were the unique technical challenges that you had to address? Maybe that's one for you again, Ansgar.
Here the focus lays on communication. Information must be exchanged reliable between the vehicle and the edge cloud. 5G can provide good services here, since the focus is on both secure and latency-free communication.
All right, sounds good. Next question maybe again to you, Ralf. Why have you actually chosen 5G as the connectivity solution of choice for this particular project here?
Well, the use case that we are developing together with our partners requires a very reliable connection, as we are moving important information into the edge cloud to enrich the behavior of the AGV. For this, the AGV needs to be connected to this edge cloud without interruption. 5G provides this high reliability in the connection and also the low latency that is needed for such use cases. With this, it is guaranteed that the messages always will arrive on time. Besides the communication to the AGV, we're also transmitting camera and laser scanner data. And those require different characteristics of the transmission channel. We have solved this by applying the quality of service concepts of 5G. With this, we are able to connect the different data streams to different bearers, which offer the needed characteristics for the respective data stream.
So thank you, that absolutely makes sense. So another question to Andreas. Andreas, why is SICK actually doing these kinds of projects?
We, from company SICK, represents the automation side, and we never have had to collaborate with companies from telecommunication before. These kind of projects gives us the chance to learn from each other. From consortia viewpoint in this project, no one can solve this challenge alone. We need the know-how from all involved disciplines, application requirements and environment to test, safety and sensors, AGV and AGV processing, telecommunication environment to use the new capabilities of reliable communication.
Yeah, sounds good. And last question again to Ansgar. Ansgar, what are the remaining challenges that still need to be addressed? And what does the interaction between the different systems look like?
Well, at the end, the form of information exchange is still under consideration. On one hand, it must be very secure, but also very effective. The vehicles themselves can detect their surroundings very precisely. This is available information that is possible customers systems can also make excellent use of in order to make the right conclusion through sensor fusion. So processes in company can be made much more effective, and this will save money.